Optical instruments. Okay, it is used to view the object as a very closer to examine it. Okay, there are the three types of optical instruments we have. One is microscope, next is telescope, and last one is spectrometer. Okay, so microscope means we have to see the object have a very small in size as a magnified in as an image. Okay, there are two types of microscope. One is called simple microscope, and that is compound microscope. Okay, telescope means we see the object very far away from us as a closer with the help of lenses and also mirrors. Okay, there are three types of the telescopes we have. Okay, one is called astronomical telescope. Okay, and next is called terrestrial telescope, and last is called refracting telescope. Okay, then third is spectrometer. Is a instrument is used to study the spectra of different sources of light. Study the spectra. Spectrum is the group of colors of light. For example, if a white light, it has 7 colors. It has name is called Vibgyor in short form. Okay, so we can see that the spectrum of the light, study and also find the refractive index of the materials and also its wavelength of the colors. Okay, now we'll see that microscope first and then telescope. Okay, in a simple microscope, okay, we are using the single magnifying lens such as a convergent lens, is the meaning of convex lens. So we are using only one lens, its name is the converging lens, okay, of a small focal length, which means it is thinner in the size. Okay, and to get erect means straight, vertical. They get the erect, magnified and virtual image. Okay, virtual image means the image is not appearing on the mirror or lens, okay, of the object. Third is we should place the object between the pole and F focus on one side of the lens, that is the left side, and image is viewed from the other side of the lens. Okay, so these 3 points are important in the simple microscope. Okay, let's see what is the magnification or discussed in the simple microscope. There are the two types of the magnification process are there. First one is called near point focusing. Okay, so near point means what is the distance? This is called the image distance is just 25 centimeter. That's called least distance. So we have to focusing with the least distance. That's called normal point focusing. Second is normal focusing. That is called angular magnification. So we can see the particular angle of the image. Okay, so we get the magnification formula for both the cases, near point focusing and normal focusing. Okay, and this is the diagram of the near point focusing. Okay, this is a convex lens. Place the object here on the left side of lens, in between, say P is here, F is here. So place the object between P and F very close to the lens. So this U is the object distance. Okay, so we place it very close to the lens means we have to see the image, it will be strained to high. Okay, but the image is falling on the same side of the object we have placed at here. The image is called D. Okay, it's called the least distance. So U is the object distance, here V or D is called the least distance. Okay, so in this kind of we have to strain our eye to see the object. Okay, that is called near point focusing. Okay, now we'll see this what is the magnification for this near point focusing. Okay, we know the formula for magnification in general. Magnification symbol is M is equal to image distance by object distance. So V by U, put the equation number 1. Okay, now we will separate the 1 by U alone. So that magnification M is equal to 1 by U into V by purpose. So we have 1 by u into v. Okay, according to that lens equation, you know 1 by f is equal to 1 by v minus 1 by u. Okay, so in this equation, what is 1 by u? Just interchange in f and u. So we will let as 1 by u is equal to 1 by v minus 1 by f. Okay, so the applying here, the magnification m is equal to, so what is 1 by u means? We will let as 1 by v minus 1 by f into v. Okay, now we have to multiply the v into the bracket, so we will let as v into 1 v by v minus of v into 1 v by f. Okay, so we have cancelled this v as a 1, so that magnification m is equal to 1 minus of v by f. Okay, now in this near point focusing, I told v is equal to d, where d is called least distance. D is called least distance, or also called image distance. So we can see the object up to 25 centimeter only. Okay, this is the meaning of d. So we place a left side, means we write as what? V is equal to minus d. According to the sign convention, okay, so we write as v equal to minus d. So applying here, so that m is equal to 1 minus v is equal to minus d by f. So minus d minus plus, so we have the formula like that, 1 plus d by f. So this is the formula for the magnification in that near point focusing concept. Okay, so d is the least distance, the value is 25 centimeter, where f is called focal length of the converging lens we are using. Okay, next we will say that normal focusing method. In normal focusing method, okay, is called angular magnification also. Angular means we have seen the object and also image in particular angle, so it's called angular magnification. Here the image is formed at infinity. Okay, image is formed at infinity. Then we have to see the eye is very most relaxed to view the image, not to strain like the normal focusing, or in the near focusing you have to strain the eye to see the image, but here we can relax to view the image. Okay, see the first diagram, so is with unaided eye. Okay, so we see the object like this. So theta naught is called angular object. O indicates object with the angular object. Is h with height of the object. Okay, this is seeing with unaided eye. Now see that the image. Okay, so the image getting the form here. Okay, is the focal length f. Okay, so here eye is focused at infinity distance of the object with aided eye. Okay, so now we will say that what is the magnification for this process. Okay, this diagram shows as with unaided eye. Okay, this is object. So generally, what is the magnification for the normal focusing means? M is equal to theta I by theta O, where I is the image, O is the object. Okay, put the equation number 1. Now we have to find the theta and theta O using these two diagrams. Okay, so first thing in this diagram, okay, here is the angle, is the opposite side, this is the adjacent side. So take the tan theta naught. So tan formula is equal to opposite side by adjacent side. So we will write as h by d. If angle is very small, we will write as a tan theta as a theta naught. Okay, so tan theta naught is as a theta naught. If angle is very small, we will write as h by d. Put the equation number 2. Now here we have to find the theta I here. Okay, same thing. Here also we have the angle here. This is the opposite side, the adjacent side. Okay, is h dash is height of the image, or h is called height of the object. Okay, see here also tan theta I is equal to opposite side by adjacent side. So h dash by f, that f is called focal length. If angle is very small, we can write as tan theta I approximately is equal to theta I is equal to h dash by f. From the equation number 3. Now we have to substitute the equations 2 and 3 in the first equation. Substitute the equations 2 and 3 in the first equation. Then magnification m is equal to theta I by theta naught. So what is it? Theta I means h dash by f. H dash by f by theta naught is equal to theta O equal to h by d. Okay. So in these cases we have same, the height of the object image also same. Okay, let us h dash is equal to h like this, so you can cancel these two. So we have 1 by f by 1 by d. So the f is diameter, come here, d is diameter by diameter, go as a numerator, so d by f. So the magnification is equal to capital D by small f. So this is the formula for magnification in normal focusing. Whereas that near point focusing, we have the magnification m is equal to 1 plus d by f. This is the formula for the near point focusing. This is the magnification for the normal focusing in case of simple pendulum. Okay.